This video introduces the demonstration experiment conducted on December 6th, 7th, and 11th, 2023. As part of the operation verification of advanced air mobility and vertiport in the R&D on advanced air mobility traffic management technologies for low-altitude airspace harmonization of the development of traffic management technology, which is one of the research and development items of the realization of advanced air mobility project promoted by NEDO. Firstly, here is an introduction to the purpose of the demonstration experiment. In this research, we plan to conduct a phased demonstration experiment in 3 years with the aim of establishing an advanced air mobility operation and vertiport operation method. In the first year, we verified the operation methods for regular flights of the advanced air mobility. In the second year, which is this year, we conducted a verification using the actual aircraft of the advanced air mobility. In addition, we used a helicopter to verify the operation methods assuming the occurrence of irregularities. Specifically, in the normal scenario, we used an actual aircraft of advanced air mobility to verify the feasibility of its operations and vertiport operations from the perspectives of differences from operational hypotheses and time required for operations. In the irregular scenario, we used a helicopter that simulated an advanced air mobility to verify the probability of operations from the perspectives of feasibility of operations implementation, especially the roles of stakeholders and methods of information coordination, and time required for operations in the event of an irregular occurrence. From now on is the explanation of the scenario of the demonstration experiment. In the normal scenario, we conducted verification on the ground for operations before takeoff and after landing, as well as verification for operations during flight. In the irregular scenario, we conducted verification for 6 irregular cases that could be assumed in actual operation, including returning to the departure airport after takeoff and landing at an airport other than the destination. Here is an introduction to the content of the demonstration experiment for the normal scenario. During the verification on the ground, we carried out operations such as passenger handling, towing operations with ground support equipment, and measured the turnaround time, which is the time between aircraft arrival and departure. Then, in the flight verification, we carried out a series of operations from takeoff to landing. The ground verification was carried out using the parking area of the Osaka Heliport. Additionally, the flight verification was conducted on a route that circles over the Osaka Bay, around the Osaka Heliport. In the verification of the normal scenario, we used a flight test aircraft from Volocopter. Here is an introduction to the content of the demonstration experiment for the irregular scenario. In irregular scenario, we conducted verification for 6 cases. Return to the departure airport after takeoff, delayed arrival at the destination vertiport, delayed arrival at the destination airport, landing at an airport other than the destination, aborted takeoff and radio failure during flight. In addition, we classified these 6 cases into 2 routes and assigned them to 2 helicopters for verification. For the verification, we used 2 routes: a round-trip route departing and arriving at Osaka Heliport, and a route connecting Osaka Heliport and Kansai International Airport. In the Osaka Heliport round-trip route, we verified cases of return to the departure airport after takeoff, delayed arrival at the destination vertiport, and radio failure during flight. On the route connecting Osaka Heliport and Kansai International Airport, we verified cases of delayed arrival at the destination airport and landing at an airport other than the destination. And at Kansai International Airport, we verified the case of aborted takeoff. In each case, we verified the probability of the operation methods discussed in this research. In the demonstration experiment, 2 helicopters were used to assess the feasibility and time required for information coordination among stakeholders before and after the emergence of non-standard situations. Additionally, the ability to maintain safe operations and accomplish successful landings during such unusual circumstances was also verified. Lastly, here are the results and challenges of the demonstration experiment. In the normal scenario, by utilizing the actual aircraft of advanced air mobility, we were able to verify the differences from the operational hypothesis and the time required for its operation. This builds upon the verification that was performed last year using a helicopter. Also, in the irregular scenario, we were able to ascertain the system and content of information coordination when the flight time is limited, from the onset of an unusual situation to landing. This was examined from the perspectives of feasibility of operations and time required for operations. However, it was determined that there is room for optimization in some operations. In the final year of the 3-year period, which is the next fiscal year, we will conduct a verification of the operation methods of advanced air mobility, assuming that the advanced air mobility will fly in the same airspace as existing aircrafts. Based on the results of this demonstration experiment, the ReAMo project will continue to work on research and development to establish advanced air mobility operation and vertiport operation methods and safety assurance procedures in the next fiscal year and beyond.